So how do we solve a quadratic equation by factoring? We use zero product property. Right, so let's do a couple of those. First, what if it's already factored? Right, then you don't have to, in this case, we've already got factored form equals 0. So we can just move right on to the next step, which is set each factor equal to 0. Right, so k plus 1 equals 0. And k minus 5 equals 0. So k equals negative 1, and k equals 5. Which you could do that one just by inspection. You don't need to set it up as an equation. If you can see that, what would you plug in there to make k plus 1 equals 0? Negative 1. What would you plug in there to make k minus 5 equals 0? 5. You don't really need to set it up as an equation, but if you want to, you can. Okay, what about the second one? I mean, what's going to be the 0 that comes from k plus 1 there?
Negative 1.
Okay, the negative 1 we've got. But this one may be not so easy. I mean, you may learn how to do it. I mean, I can tell you it's got to be negative 5 over 4, because I need a 4 in the denominator to cancel the 4, which is multiplying, and I need a negative 5 to cancel the 5. But it might be better to make an equation 5k plus 5 equals 0, and then solve it. Subtract 5, divide by 4. So those are the answers. K equals negative 1, and k equals negative 5 over 4. So notice we solved two quadratic equations. They were in a factored form. You may not recognize them as quadratic, but you know, if I FOILed k plus 1 times k minus 5, the first term would be k squared. Okay, so it's a quadratic. But how many answers did we get with a quadratic? 2, right? And so that's normal. We saw later when we did by graphing that sometimes you only get 1, right? And sometimes you get none. Sometimes it'll be a quadratic equation that if you turn it into a function, it never crosses the x-axis, therefore no solutions. So, but 2 is the most you could get. You know, but the truth is that not all quadratic equations are factorable. Sometimes you look at that last number and you say, what are the factors of that number that add up to the middle number? And none do. None. Right? So these are all very specially constructed so that they'll work, because they don't have to work. Okay, now, what if it's not already in factored form? Then you factor it. Okay, the first one, at least we have an expression on one side, which is set equal to 0. So we don't have to do that step. How do you factor 7x squared plus 2x? What kind of factoring would we do? We don't call it guessing. We have no methods that are called guessing. Go down the list of all the factoring. Here's right here. Greatest common factor, right? I mean, certainly the kinds of factoring that have trinomial in their name, it's not going to be that because there's only 2 terms, right? The only other kind of factoring that we did that might have just 2 terms, that's difference of squares. This one's, it's not even a difference, let alone the fact that neither 7 or 2 is a perfect square. So the only kind of factoring that we should be thinking of is greatest common factor. Okay, what's the greatest common factor between those 2 terms?
14.
No. What's the factor that's in common to both of these, right? Not the least common multiple, but the greatest common factor is x. Okay, what's left? If I factor an x out of 7x squared, what's left? 7x. And if I factor an x out of 2x, 2. Okay? So now I've got factored form equals 0. What are the solutions? I mean, again, set the factors equal to 0. Okay, the first factor is x. X equals 0. So there you go. There's your solution. right? When you just have an x and it's not x plus something or x minus something, then x equals 0 is the solution. And the other one is going to be negative 2 over 7, but I can show you by doing 7x plus 2 equals 0. Subtract 2, 7x equals negative 2. Divide by 7, negative 2 over 7. Okay, how about the second one? What do we have to do to that one that we didn't have to do on the first one? We need a 0, right? We got to have a 0 on one side. So, as Sarah says, we'll add 5, right? Add 5. Here and here. Right, now we have x squared minus 11x plus 24 equals 0. Okay, what kind of factoring can we do on the left side? Yeah, the simple kind, right? Because it's just 1x squared. So all you have to think of is, what are the factors of 24 that add up to negative 11? That 3 times 8 is 24, but they don't add up to negative 11. But you're close. Negative 8 and negative 3, right? Remember, if the last number is positive, either both the numbers you're trying to think of are positive or they're both negative. But they add up to a negative number, so they got to be negative. So this should have been x minus 3 times x minus 8 equals 0. So what are the solutions? Without setting up equations, just tell me what are the solutions. 3 and 8. Right? X equals 3, x equals 8. You got it? Okay, let's go. Didn't go forward. There we go. Is that it? Yes. Okay, so the other way we had to solve an equation was to solve it by graphing, right? And if we graph a quadratic function, what's the shape of the graph? It's a U and it has a word that we use. It's called a parabola, right? It's called a parabola. You should know that. We're not going to go as deep as we should, or that you will later, about quadratic functions. But at the very least, we should know what the graph is, right? Now we know 2 graphs. We know linear and we know parabola. We know what their basic shape is. Right? That's the basic shape. So the parabola can open, it's like a U. It can open up or it could open down. It's symmetric, meaning that it looks the same on one side of it as it does on the other. If you draw a line right through the middle of that, then look on the left and look on the right. If that line in the middle was a mirror, that's what it would look like on either side of the mirror.
Please excuse the interruption. At this time, with those students that are going on the Youth Career Expo field trip, please report to the Commons. Thank you.
Right. So the reason we can use graphing to solve an equation. Remember, an equation, something like the one we just had, right? Something like x squared minus 11x plus 20. Oh, sorry. Yeah, plus 24. I did that all wrong. Let me get that right. Let me get that back again. Minus 11x plus 24 equals 0. An equation doesn't have a graph. Okay, there is no graph of that equation, right? Because there's no y in it. The graph has an x and a y coordinate, so you need another variable, right? It becomes a function when instead of having a 0, you've got a y. So if we turn it into y equals x squared minus 11x plus 24. Now that's something we can graph, and that's something that will, Suf, stop talking. Okay, that's something that we can graph. It'll be infinitely many points. It'll have a distinct shape, which is because of the kind of function that it is. And we'll know that the solutions to the equation that we started with will be where y equals 0, right? Because where y equals 0, then this becomes this. Well, where on the graph does y equal 0? Of any graph, where does y equal 0? On the x-axis. So what are we looking for when we solve by graphing? The x-intercepts. Wherever it crosses the x-axis, those are going to be the solutions to the equation. So how do we solve the quadratic equations by graphing? With the calculator. At this point, just with the I mean, honestly, if we didn't do it with the calculator, you would learn in, but we don't even do that much with it in Algebra 2, but you can learn how to graph parabolas by hand, without using the calculator. But just like when we tried to solve a system by graphing, if your graph isn't 100% accurate, then your ability to get an accurate intersection point is going to be limited, right? Same thing here. If we do our best to graph it like we learned to graph parabolas, you would still be kind of estimating what the solutions are. But with the calculator, we can find them exactly. Okay. So we're going to rearrange the equation. We need to have 0 on one side, and then we'll enter the function at y equals. Right? The y equals button is where you enter functions. Right? That's all you can put there. Right? And the solutions of the equation will be the x-intercepts of the graph. Okay. So let's do these couple. What do I have to do first step? No. It's going to have to get a 0 on one side, so we need to add 2, right? So this will become n squared minus 10n plus 24 equals 0. Okay, that's first step. Second step, put it in a calculator. So go to y equals, turn on the calculator, there we go. And n squared minus 10n, well, we're going to use x squared. X squared minus 10n plus 24. And then graph. Right? If you're doing that with me right now, if your graph doesn't look like that, maybe the zoom is different, how can you make the calculator go back to this view? What's that? You don't have to do all that. Just say zoom 6. Zoom 6 will get you back in the middle of the graph. So if that's my graph, where do I look for the solutions again? The x-intercept. So how many do you see? 2. And can you estimate what they are? 4 and 6. How could you confirm that? Go to the table, right? So second table, and look for x equals 4 and x equals 6. And what do you expect to see for y? 0. Yes?
It's same. I mean, the wrong term actually.
Sometimes if especially when the calculator gives you like a dimension error, clear the memory, try it again. It'll probably work. Okay, let's try the other one. So this one, 4 and 6 were the answers. X equals 4, or I should say n, to be proper, because it was an n and not an x. N equals 4 and 6. So, I mean, this one was easily factorable, right? This would have been x minus 4 times x minus 6 equals 0. Okay, how about this next one? Let's subtract 6. Put it on y equals 6, negative 18, and 24. I think that's right. Right? And then look at the graph. So it looks like the parabola is going off the screen to the bottom and the top, which is fine. Can we see the x-intercepts? Yeah, you can. You know, there's one of them looks like it's at -1, and one looks like it's maybe at 4.
Yeah.
Is that right? Okay, so then let's confirm in the table of values. Second, and let me make that big again. Okay, 4, when x equals 4, y equals 0. When x equals -1, y equals 0. So there's our answers. N equals -1 and 4. That's solving by graphing. So what do we mean by 0 of a function? Well, remember, the 0 of a function is just like saying the x-intercepts of the graph, right? I mean, it literally means the x values that make the function equal 0. They are the solutions to the equation we started with, and sometimes the solutions to the equations are called roots. So you can see all 4 of those kind of used in the same way to mean the same thing. Zeros, x-intercepts, roots, solutions, kind of the same thing. The thing not to get confused with is, after we've done this thing, and then we get to a system of equations, remember that the system of equations solution is the intersection point of the graph. Don't look for where the lines are crossing the x-axis, because that's a different thing, right? That's this. Okay. So how much time do we got? Okay. Okay, so let's find the zeros of these equations. Now, because they're actually already in factored form, you might be able to just tell them by looking at what the zeros are. But we could also do by graphing. I mean, it would show you one thing is, what you put in the calculator at y equals, it doesn't have to be in standard form. It could be in any form. It could be in partially factored form, and totally factored form, standard form. Calculator will work all of that out. So let's do this one just to show the one last thing, which is, what do you do when the 0 is not an integer? A whole number plus or minus. So let's try this. F of x equals 2x minus 1 times x minus 5. And remember that f of x is like saying y. So you're really, what we're putting in the calculator is y equals 2x minus 1 times x minus 5. So here I go. Calculator. Y equals, clear, parentheses, 2x minus 1 times x minus 5. And when I hit the graph button, I know I'm going to get 1, 0, which is 5, right? And sure enough, you can see it on the graph. but what does it look like the other 0 is? It's close to 0, but does it look, let's zoom in. So here's another thing you can do with your calculator, right? You can zoom in to see it better. So zoom, and it's the second option, zoom to, and you have to hit enter. And now we see it come down, and it's not at 1, it's not at 0, it's in between 1 and 0. It looks like it's probably 1/2, and it is 1/2. Sometimes it's not that easy to get like that. But remember, there was that third way to find the 0 by graphing, which involved a little bit of steps, which is to do like this. Go second, trace, 2 for 0. Second, trace, 2 for 0. And now it's going to ask you left bound, right bound, guess as questions. By left bound, it means put in an x value which you know is to the left of the 0. So it could be anything on the graph here. It could be 0, -1, -2. You could also move your cursor so you can see that it's to the left. I mean, it looks like the cursor right now is at the point 0, 5. So I don't even see it. I actually have to right arrow so that I can see it on the screen. There it is. Do you see the cursor? It's blinking above and a little bit to the left. That's a left bound. So I hit enter. Okay, now it asks for right bound. I can use the arrow to scroll down below the x-axis, which is also going a little bit to the right. That can be a right bound. And then, you know, when I did the left bound and right bound, you see the triangles that it put above the graph, above the x-axis? They're asking, are you comfortable where you put the triangles? And if you are, you hit enter. I mean, you always do at that point. And it jumps to the 0. It says the 0 is 0.5, 1/2. So if you guessed 1/2, you were right. So the zeros are x equals 5 and x equals 1/2. It says try to do the same thing with the other one. Right, put that f of x, it's got 3 factors to it. Clear. X minus 3 times 3x plus 1 times x plus 1
I can't wait to see it. Whoa. What? It's like all,
So that's not a parabola, is it?
that's like,
That's actually a cubic function, what a cubic function looks like. But we don't really care. All we care is where are the x-intercepts. How many x-intercepts does it look like are there?
3.
It looks like there's 3, right? And let's see. It looks like 1 is at 3 and 1 is at -1, but I can't see what else is going on. First, I'm going to check the table. And sure, at -1, y is 0. At x equals 3, y is 0. So those two we've got, right? X equals -1 and x equals 3. But looking back at the graph, that other one doesn't show up, but it looks like it's close to 0. So again, what could I do? Zoom in. Zoom in. Zoom to, enter. And there you see that second 0, which is, you know, in between -1 and 0, maybe a little closer to the 0. I mean, can you estimate what it's going to be? Okay, let me do the second trace 2. Second trace 2. And for a left bound, let me cursor over to, see my cursor is going a little bit above that 0, which makes it a little bit to the left, and my right arrow a little bit below that 0, which makes it a little bit to the right. And I'll hit enter. And it looks like it's negative 0.333333. What number is that? It's 1/3. So negative 1/3. Which comes from this factor here, 3x plus 1. You know, what is it that you would plug into that x to make that factor equal 0? Negative 1/3. What time is it? Okay. So I think what I'm going to do is, I'm just going to give you the study guide to start on. But I would suggest you start at the bottom because it's got the solve by graphing and you have a calculator in your hand now, right? Don't save it till last and then say you walked out of here and you didn't get a chance to do it. Okie dokie.